Assalamu alaikum. Am I audible?
Salam, sir.
Walaikum salam, sir. Yes, sir.
Okay. So do you have any doubt from last class?
From my side, no, sir.
Okay. We had completed potential energy due to a spring and gravitational potential energy as well. Okay. Now, on the basis of this term, if you have to apply work energy theorem for this potential energy or kinetic energy, so work energy theorem. So it should be work done is equals to potential energy final or potential energy initial. This work done will be either due to any external force or due to any non-conservative force. Just 1 minute. So you will say the change in potential energy either due to gravitational potential energy or elastic potential energy will be equal to work done by external force or by non-conservative force. For this, you'll be asked one question. If a spring mass system on displacing by 2 centimeter stores U amount of potential energy, find work done to displace it further by 4 centimeter. Try to solve this part. Let's say a spring mass system, which is initially at this point. So this will be termed as mean position on displacing spring by 2 centimeter. Let's say this point. Stored potential energy is U. So find work done to displace further it by 4 centimeter. Try to solve. Just see how to solve it. For spring mass system, try to define displacement of block from starting, that is from mean position. So in first part, displacement is from this point to this point, which is just 2 centimeter. Now in the second part, we have given displacement further from this point to this point is 4 centimeter, but we have to define from origin or mean position. So in total, it will be 6 centimeter. So U is equals to K times displacement, which is 2 square. Let's say this particular term to be initial or UI. Similarly, potential energy final will be half K. Total displacement from mean position will be 4 plus 2 whole square. So it will be 6 squared. So on solving this, you will get 4 times half kx squared, or 2 and 2 will cancel out. So you will say 2 times of kx squared. Just 1 minute. Since displacement in this case is in centimeter, so just divide it by 100. So you will get k over 2, 4 divided by 10,000. Or if you solve it further, you will get 2k into 10 to the power minus 4 as u. Similarly, if you solve for this part, it will be divided by 100. So it will become k divided by 2, 6 into 6, so it will be 36 divided by 10,000, or we can write it as 18k into 10 to the power minus 4. Now, if you relate this particular term with respect to previous term, you can say it will be 9 times as greater than for this part. So it will be 9 times U. Now, according to work energy theorem, it will be change in potential energy from final or initial. So work done is equals to potential energy final minus potential energy initial. So it will be 9U minus U. So it will be 8 times of U. Is it clear how I am defined in terms of U?
Yes, sir.
Hishma, any doubt?
So can you say how you got 9U?
Okay. Since initial is 2k into 10 to the power minus 4 on solving this particular term, which is nothing but U according to the question. So on solving this final potential energy, we get 18 in k in 10 to the power minus 4. So 18 is nothing but 9 times of 2. That's why I've written 9U. Or you may
Okay, sir.
divide these two terms to get final in terms of U.
Okay, sir.
Okay. Now, according to work energy theorem, work done will be equals to change in potential energy. So it should be potential energy final minus potential energy initial. So it will be 8 times U. Salman, any doubt?
No, sir.
Okay. Have you all done the above part?
Yes, sir.
Okay. And there is another question. Let's say we have two spring, one is A and the other is B, and there is a relation between spring constant as Ka is greater than Kb. So we have to define the relation of work done on each spring mass system if same force is applied on each system, and second, if same displacement is done for each mass block system. So for in which case W1 will be greater than WB or WA will be smaller than WB. Try to define. Just see how to solve it. In first part, we have given same forces applied. So it will be force on A equals to force on B, as force is equals to spring constant into displacement. Similarly, spring constant into displacement. So move this Kb to the other side, you will get Ka divided by Kb is equals to Xb divided by Xa. In this ratio, as Ka is greater than Kb, so you will say Xb will be greater than Xa. So it will be like this. Is it clear till this part? Hamza, is it clear?
Yes, sir.
Now we have got the relation between displacement for two spring. Now work done is nothing but force times displacement. So if you want to calculate work done A is equals to force in A times displacement. Similarly, work done in B is equals to force times displacement in B. Just divide these two terms. Force in A and force in B are equal, So these two terms will cancel out. So we're left with xa divided by xb. Now I define in the above part, xb is greater than xa, so you'll got a ratio to be less than 1. Now, from this part, we can say work done in A will be smaller than work done in B. Hiba, is it clear?
Yes, sir.
Similarly, if we do the same term for the next, if spring is stretched by same displacement, which means XA is equals to XB. So force in A is equals to K times A into XA, and force in B is equals to K times B into XB. As displacement in these two terms are equal and Ka is greater than Kb, so you will say force in A should be greater than force in B. Is it clear? Hishma, is it clear?
Yes, sir.
Now, work done in A will be force times displacement in A. Similarly, work done in B is equals to force times displacement in B. Now, if you divide these two terms, displacement in both spring is same, so you will get force in A divided by force in B. As we defined above, force in A is greater than force in B, so you will say work done in A will be greater than work done in B. So this is how we define relation for work done for two different conditions, if it's stretched by same force or stretched by same displacement. Have you all done till this part?
Yes, sir.
Yes, sir.
Salman?
Yes, sir.
Okay. So this is how to define potential energy or change in potential energy according to different work done. Next is, if we combine these two different work energy theorem together, so we can say, in general, work energy theorem on combining them together will be net work done is equals to change in kinetic energy and change in potential energy. This work done will be due to, just 1 minute. So this work done will be mainly due to external force and due to any non-conservative force. Kinetic energy change will be kinetic energy final and kinetic energy initial. Change in potential energy will be of two different types. One is due to gravitational potential energy. So it will be potential energy due to gravity final minus potential energy due to gravity initial, or it will be due to elastic potential energy that will be due to spring mass system. So it will be potential energy final minus potential energy initial. So in general, the net work done or work energy theorem will be like this. Is it clear? Hamza, is it clear?
Yes, sir.
I'm defining you a question related to this. Suppose you have a surface and there is support. A spring attached to this and there is a ball or a block which is going toward it at some velocity v. Now suppose there is a rough surface on this path which offering some friction. So we have to calculate maximum compression in this spring by this ball. Let it be to this point. So the displacement from this will be like this. So we have to calculate, find maximum compression in spring. So how to define it? Use the above work energy theorem. Since in this path we have both movement of ball, so it must have some kinetic energy change, and there is a spring also, so there will be some change in elastic potential energy. Since this whole system is on same horizontal path, so there is no change in gravitational potential energy. So we can neglect this part in this expression. Now, how to define it? First, work done due to friction will be frictional force times displacement. Since path is horizontal, so frictional force will be mu times normal reaction. So it will be mg, and displacement is x. This work done is due to frictional force, so it must be in opposite direction of displacement. So work done will be taken as negative. Is it clear?
Yes, sir.
Khalid, is it clear?
Yes, sir.
Now, try to define initial and final for kinetic energy as well as potential energy. Elastic potential energy initial, as there is no any compression in the spring for this part, so initial displacement will be zero. That's why initial potential energy will be zero. Elastic potential energy final, due to this much compression, will be half times kx square. Similarly, initial velocity of body is v for which it will have some kinetic energy, which is equals to half mv square. And finally, on getting maximum compression, it will get stopped. So final kinetic energy will be 0. Now put all these values in this above equation or expression, you will get work done is equals to kinetic energy final minus kinetic energy initial plus elastic potential energy final minus elastic potential energy initial. Work done is minus of mu mgx. Kinetic energy final is 0 minus kinetic energy initial is half m velocity square. This is v. Elastic potential energy final is half kx square, and elastic potential energy initial is 0. So we have to calculate x from this expression. So move each term to one side. So if you move each term to one side, you will get half kx square as positive. If we move this term to right hand side, you will get mu times of mgx minus half mv square is equals to 0. Or we may rearrange this expression to get a quadratic equation. So it will be x square plus 2 times of mu mg divided by k as coefficient of this x minus m v squared divided by k as constant term is equals to 0. Use quadratic formula to find x. Is it clear till this part? How I have taken each component and used work energy theorem? Ishma, any doubt?
No, sir.
Okay, just write it down. You may assume this particular expression as ax squared plus bx plus c is equals to 0. So using quadratic formula, you will get x is equals to minus b plus minus root under b square minus 4ac divided by 2 times of a. Now there is some condition to this particular problem. Let's say if surface is smooth, which means there will be no friction, so mu in this condition will be 0. So now put value of mu in this above equation, you will left with x squared minus mv squared over k is equals to 0. And then you will easily calculate the value of x. Is it clear?
Yes, sir.
Khalid, do you have any doubt till this?
No, sir.
Okay. Have you all done?
Yes, sir.
Yes, sir, done.
Okay. So this is all about work energy theorem using kinetic energy, potential energy, elastic, and gravitational. Now, on the basis of this, we can define conservation of mechanical energy. Let's say using work energy theorem, work done is equals to change in kinetic energy plus change in potential energy. So if work done on that particular system is 0, so if work done is 0, so we will say change in kinetic energy and change in potential energy will be 0. So if you break this down, you will get kinetic energy final minus kinetic energy initial, potential energy final minus potential energy initial, move initial term to left hand side, you will get kinetic energy initial plus potential energy initial is equals to kinetic energy final plus potential energy final. So we can say sum of kinetic energy and potential energy at initial point is termed as total mechanical energy initial. Similarly, kinetic energy plus potential energy for final position will be termed as total mechanical energy for final. So this is nothing but they are equal. So we can say if there is no work done by any external agency or non-conservative force on the system, then sum of all mechanical energy at any position will be always conserved or constant. So from this we can conclude if there is no work done on system, then total mechanical energy at any instant will be conserved. Hamza, is it clear till this part?
Yes, sir.
Okay. Have you all done?
Yes, sir. Done.
Salman? Okay, I'm giving you one problem related to this.
Yes, sir. Sir, I couldn't speak.
A ball is thrown upward at 30 meter per second. Find maximum height it will attain first. Second, velocity of ball at half of maximum height. Suppose this is ground from which a ball is thrown upward at some velocity 30 meter per second. So it will move along this path to reach the highest point. So for highest point, velocity of body will be 0. Using third equation of motion or using conservation of mechanical energy, you will say or you will be able to calculate total height attained by the body. Now we have to calculate velocity of body at this instant, which means at half of maximum height attained by the body. So velocity would be v. Just use conservation of mechanical energy as there is no any external agent applying work done to the system. So let's say this is point A, this is point B, and this is point C. Calculate total mechanical energy at A, B, C, equate them to calculate H and velocity. Is it clear, Khalid? Iba, is it clear? I'm giving you some hint how to calculate total energy. Let's say total energy at point A will be half m velocity at point A, 30 square. Height of ball at this A will be 0, due to which potential energy at A will be 0. So this is your total energy at point A. Total energy at point B will be, as velocity of ball is 0, so kinetic energy will be 0, mgh. So we have gravity as 10. Just equate these two terms, you will get height attained by this ball. Similarly, energy at point C will be half m b square, and potential energy will be mgh by 2. Just equate this term to any of the two above, you will get velocity. Try to solve. Take gravity as 10. Equate first and second. From this, you will get h. Then equate first and this. Put the value of h, and then you will be able to calculate v. Or let's say velocity at some point c. Good, Ishma. Should I solve? Just equate energy of A and energy of point B. Energy of point A is half m and 30 square, so it will be 900, is equals to energy at point B is m, gravity is 10, and we have to calculate height. Good, Hamza. So mass and mass will cancel out. So h will be equals to 900 by 2 divided by 10. This 0 and this 0 will cancel out. 90 divided by 2 will be 45 meters. Now put these values in this second equation. Just compare energy at point A to energy at point C. So it will be half m 900 is equals to energy at point C is half m velocity at C, which we have to calculate, plus m, gravity is 10, and height is 45 divided by 2. Take it common, so they will cancel out. So 900 divided by 2 will be 450 is equals to velocity at point C by 2 plus it will be 225. Move this 225 to other side. It will become 225 is equals to velocity at C divided by 2. Move this 2 to the other side. you will get velocity at c square is equals to two into 2 to 5. So move square to the other side, you will get velocity at c is equals to root under 2 into 2 to 5. 2 to 5 on square root will be 15 and root 2 meter per second. So this will be a final answer for velocity at point C. Ishma, is it clear?
Yes, sir.
Iba, in and out?
No, sir.
Okay, just write it down. I'm giving you one more problem related to this. A ball from 10 meter height is thrown downward at 10 meter per second. Find maximum height it will regain on bouncing back. In this part, suppose this is surface. So a ball from this height is thrown downward with some velocity 10 meter per second. On hitting this surface, it gets rebounded back along this path to reach at this point. So let's say this is point A, this is point B, and this is point C. Try to calculate total energy at point A, total energy at point B, total energy at point C. Just equate them, and then you'll be able to calculate velocity, height, and so on. We have total energy at point A as half m velocity at A, potential energy half m over mgh at point A. Similarly, for B part, it will be half m velocity at B square. And since there is no height of ball, so potential energy will be 0. Similarly, energy at this highest point, since velocity at highest point will become 0, so it will be 0 mg height at point C. Just equate any two terms, you will be able to calculate velocity at point B. Then equate the rest of the term to calculate other height. Or you may compare this term to this term directly to calculate height. Try to solve. Just compare first and third equation. We have velocity at point A as 10 meter per second. Height at point A is 10 meter. Gravity is 10. Just compare these two terms. You will get velocity height at point C.
Sir, do we have to take the height to be 10 at C also?
No, we have to calculate height at point C
Yeah,
by
sir.
comparing first and third equation.
Okay, sir.
Velocity is given as 10 meter per second. Height at point A is also given as 10. From this, you will be able to calculate height at point C. Good, Hiba. Good, Hishma. Good, Hamza. If you put values in this equation, m will cancel out. Velocity at A is 10. So it will be 10 into 10 divided by 2. Gravity is 10. Height at point A is also 10, is equals to gravity is 10 and height at point C, which we have to calculate. So 2 into 5 will be 10. So it will become 50 plus 100 is equals to 10 times h. So this will become 150 is equals to 10 times of h. So h will be equals to 150 divided by 10. So this 0 and this 0 will cancel out. So you will get just 15 meters for this height at point C. Similarly, if you compare first and second equation or second or third equation, you will be able to calculate velocity at point C or velocity with which it will hit the ground. So just compare equation B with equation C. Try to find velocity at point B.
So what do we have to find?
We have to find velocity at point B. This part, we have lost height at point C as 15 meters. So m and n will cancel out. Put the value of gravity at height and try to find velocity at point B.
Okay, sir.
Good, Ishma. VB squared divided by 2 is equals to G, which is gravity having value 10. Height we have calculated as 15. Move this 2 to the other side, you will get VB squared is equals to 2 into 10 into 15. So it will become 300. So VB will be equals to root under 300, or it will be 10 root 3 meter per second. Is it clear, Hamza?
Yes, sir, I found it, but I was searching for root sign.
Okay. Khalid, is it clear till this part? Salman, any doubt?
No, sir.
Okay. Okay, as I'm not well today, so let's stop here. In next class, I will continue, and then we will do collision, the last part of this chapter, and then circular motion. Okay?
Okay, sir.
Okay then. Allah Hafiz.
Okay, sir. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Yeah.
And get well soon, sir.
Okay.